I'd like to take a look at evaluating functions and then evaluating first and second derivatives at particular values of x. So here's a function that I've graphed. Sine of x plus cos of the natural log of x. And let's say I'm interested in knowing the value of the first and second derivatives when x is 4. All right. So we can graph those. Menu down here in that red button, choose that first derivative looking one. That gives us the first derivative, and we want to type in the first derivative of f1 of x, because that's my blue function there, and that gives me a red curve. And if I want the second derivative, same button, same menu, d squared dx squared of f1 of x. So there's my original function, my first derivative, and my second derivative. So probably the easiest way to do this is using graph trace. So we're interested in that value x equals 2. Okay, let's go with x equals 2. If you go into menu, trace, graph trace, and simply type in 2, it will take you to the value on the original function. So there's f of 2. If I want to know the value of the first derivative when x is 2, now all I need to do is put the down arrow, and that will cycle between the functions and keep the x coordinate. Okay, so we can see that the first derivative is negative. Is that something that makes sense? Yes, it is. Through here, this graph is negative. The second derivative is negative when x equals 2. Is that something that makes sense? Yes, this graph is concave down here. You can also cycle through. Okay, so there we go. We've hit a relative minimum on my original function. If I look at the derivative function, its value is 0. And if I look at the second derivative, see how the x-coordinate hasn't changed. The second derivative is positive. What does that mean? It means that this is a relative minimum because the gradient is 0 and the concavity is positive. Concave up means a local minimum. So that's what you would do with a graph if you wanted to find, evaluate functions, first derivatives and second derivatives for a particular given x value.